Welcome to In 5 Minutes. We take problem on bending stresses. A problem statement is a rectangular beam 200 mm deep and 300 mm wide is simply supported over a span of 8 meter. What uniformly distributed load per meter the beam can carry if the bending stress is not to be exceeded 120 Newton per mm square. So we first draw the figure of a given section. So this is a rectangular section 300 mm wide and 200 mm deep, and this beam is simply supported at point A and B, and a uniformly distributed load of W of Newton per mm is acting on the beam. So in this problem we have been asked to find this value of W if the bending stress is not to be exceeded 120 Newton per mm square. So let's solve the problem. First we denote the support reactions of this simply supported beam. For this beam which is loaded symmetrically, the vertical support reactions at point A and B will be given as WL by 2 and WL by 2 respectively, where L is the span of the beam equal to 8 meter or 8000 mm, which is given in the problem. So we note down the given data, which is maximum bending stress is not to be exceeded 120 Newton per mm square, and in the problem we have to find the intensity of uniformly distributed load W. So now let's solve the problem. We know we have this rectangular section which is symmetrical about the centroidal x-axis axis, and for the given loading condition, vertical loading upon the simply supported beam, your beam will be under sagging moment, so that the upper layers will be under compression whereas the bottom layer will be under tension. So due to the symmetry, the centroidal x-axis axis passes through the center of the section such that your centroidal x-axis axis is neutral section, and the layers above the neutral axis is under compression and the layer below the neutral axis is under tension. So if we plot the bending stress variation diagram for this rectangular section under sagging moment, we see that above the neutral axis at a distance of yc max we have compressive stress as maximum, and at the same vertical distance below the neutral axis yt max we have tensile stress as maximum. Now to find out the intensity of loading, we make use of the bending equation, which is given as maximum bending moment Bm max is equal to moment of resistance of the beam. Now for a simply supported beam with uniformly distributed load over the whole span, the bending moment maximum is given as WL square by 4. Now this is equal to moment of resistance of beam is given as sigma B max upon Y max into moment of inertia of the section about centroidal x-axis axis. Now this moment of resistance could be in terms of compressive stress, so that your Y max becomes YC max, and if you consider the bending stress as sigma T max, your Y max becomes YT max. So upon substituting the values, we get W into L square is 8000 square upon 4. This is equal to, now since our section is symmetrical section about the centroidal x-axis axis and neutral axis, we have sigma C max is equal to sigma T max is equal to sigma B max, which is given in the problem. So we have sigma B max as 120 Newton per mm square, and Y max is again same, which is 200 divided by 2 equal to 100 mm multiplied by moment of inertia of section, which is given as 300 into 200 cube upon 12. So upon solving this, we get the value of W as 15 Newton per mm or 15 kilonewton per meter. So this is a uniformly distributed load 15 km per meter which the beam can carry if the maximum bending stress is not to exceed 120 Newton per mm square. So this is our answer. With this, our problem is solved. Thanks for watching In 5 Minutes.